All right, in this section, we're going to look at rational equations and inequalities. So we're going to start with rational equations. We'll break this objective up into a couple of videos for time purposes. And in this section, we're going to look at equations that contain rational functions. So you're going to see variables in the denominator, maybe in the numerator as well. So similar to the technique for simplifying complex fractions, we're going to eliminate our fractions in our equation by multiplying everything on both sides by the least common denominator. So that'll clear out all of our fractions, just like the least common tiny denominator. When you multiply the complex fraction by it, will clear out the tiny fractions. So we are solving equations, so we will be finding values of x or whatever letter we're using. And because our fractions contain variables in the denominator, we're going to have to remember that the denominator can never equal 0. So we're going to have to check for extraneous solutions when solving rational equations and inequalities. In other words, we might get some values of x in our answers that go against the values that we're not allowed to have. So example 1, solve each of the following. And again, please remember to check for extraneous solutions. We have 1 over 5x equal to 1 over 5x squared minus x plus 5 over x squared. So we have a 5x squared, and an x squared. So looking at our coefficients, our coefficients of 5 and 5, well, there's a least common denominator is going to have a 5 as a coefficient. And then x versus x squared, remember, we always take the highest power of the variable we have. So we have a 5 and an x squared. Our least common denominator is 5x squared. Now, also, going to list the condition here that x is not allowed to equal 0. So if x equals 0, we're going to get 1 over 0, which is no good. So, and again, our least common denominator is 5x squared, so we are going to multiply every single term, all three fractions, by 5x squared. Guaranteed to clear out your fractions or your money back. So multiplying every single term by 5x squared, over on the left, we have 1 over 5x times 5x squared. The 5's will cancel. The x squared, one of those x squared is going to cancel with an x in the denominator. So we're just going to have an x on the left-hand side. Over on the right, 1 over 5x squared times 5x squared is just 1. And then we'll bring down the minus. And then x plus 5 over x squared, when we multiply that by 5x squared, the x squareds will end up canceling each other out, leaving us with 5 times x plus 5. So now we have no more fractions, and we're dealing with x equals 1 minus 5 times the expression x plus 5. So distributing our negative 5 to both terms, on the right we get 1 minus 5x minus 25. And if we add 5x to both sides and combine 1 minus 25 on the right, we're going to get 6x on the left, and 1 minus 25 is negative 24 on the right. And divide both sides by 6, and we get x is negative 4. And if we check this, we could plug it back into the original problem. We could also look at the graph of y equals 1 over 5x and y equals 1 over 5x squared minus x plus 5 over x squared. And we will see that the graphs intersect when x equals negative 4. Also, we didn't get x is 0 for an answer, so that's good. So negative 4 is our correct answer. All right, part B, we have 5/3 minus 1 over x equals 1 over 3x. So we have a 3, an x, and a 3x. We're going to, again, note that x cannot equal 0 because it would cause at least this fraction to have a 0 in the denominator. So 3x and 3x, our least common denominator is going to be 3x. So multiply everything by 3x, it'll clear out the fractions. So let's do that. On the left, we're going to have 3x times 5/3. The 3's cancel out, and we'll just have a 5 times x. And then bring down the minus. And for 1 over x times 3x, the x's cancel out, and we have 3 times 1, which is 3. So on the left side, we have 5x minus 3. And then on the right side, 1 over 3x times 3x is just 1. So the 3x's cancel out. So then add 3 to both sides and divide by 5, we get x is 4/5. And if we check the intersection of 5/3 minus 1 over x with the intersection of 1 over 3x, we'll see that they do intersect at x equals 4/3. And that's not equal to 0, so that's good too. All right, part C, we have 1 over x plus 4 equals 6x minus 42 over x squared plus 4x plus x minus 8 over x squared plus 4x. So went ahead and just factored everything. 1 over x plus 4 doesn't factor, but on the 6x minus 42, we have 6 times the expression x minus 7. We can factor out a 6 as the greatest common factor of this first numerator on the right. And then x squared plus 4x, we can factor out an x, and we get x times x plus 4. Same thing with the denominator in the last fraction. So we have an x plus 4 in each one, and we have an x as well in these other two. So our least common denominator will be x times x plus 4. And the values of x that we're not allowed to have are 0, because it would make either of these two fractions on the right have a 0 in the denominator, or a negative 4 for the same reasons. So again, our least common denominator, x times x plus 4. We multiply everything by x times x plus 4. On the left, the x plus 4s are going to cancel out, and we'll have 1 times x on the left, which is just x. Over on the right, 6 times x minus 7 over x times x plus 4. When we multiply that by x times x plus 4, the x times x plus 4s cancel, and we're left with 6 times x minus 7. In our last fraction, x minus 8 over x times x plus 4, when we multiply that by x times x plus 4, these x times x plus 4s cancel out, leaving us with just x minus 8. So with no more fractions, we have x equals 6 times the expression x minus 7, and then plus x minus 8. Well, distributing the 6 through, we get 6x minus 42, and then combining our like terms, on the right-hand side, we get x equals 7x minus 50. So subtract 7x from both sides, you get negative 6x equals 50, and then divide both sides by negative 6, and negative 50 over negative 6 equals 25 thirds. Which is nice because it's not 0 or negative 4. So, all right, that about does it for this video. Thanks for watching, and I'll see you next time.